Okay, next we have question number 9, section B and paper 2 for maths, yeah? So let me redraw this diagram because I prefer a bigger one. And I prefer to scribble my own diagram. Okay, so this is RST, 90 degree, O, and this is theta. And then we have this one over here. This is P, this is Q, and this is R. Now let's check with the word problem, okay, with the question. In this diagram, ORQ. Where is ORQ? ORQ. ORQ. Over here, ORQ is a right angled triangle. So let's put down, this is 90 degree over here. And then the PR is an arc. PR, P to R is an arc of a circle with center O and radius 8. So this is the information. Here is 8. All right. And then the ORST. ORST is a quadrant of a circle with center O as well. So quadrant will be subtended at 90 degree over here. And the ratio of OP to PQ. Where's OP? OP to PQ is 2 parts here, 1 part here. Okay, we know that this one is 8. So we need to times 4 to give us 8, isn't it? So if this is 8, so 1 part also we times 4, we will have this one to be 4 cm. So this one will be 8 cm. So we get this information. Now we can calculate. Okay, what do we want? We need to find the value of theta in radian. Okay, first part, you need to find theta in radian. Second part, we need to find the perimeter of the shaded region. Okay, and then third part, we need to find the area of the shaded region. Okay, these are the 3 things we need to solve. Okay, first part. Okay, what else do we know? We know that this is 8, this is triangle, this is 8, and then the hypotenuse is 12, right? So let's take that triangle out so that will be more focused. This is a right angled triangle whereby this is 8 and this is 12. Therefore, we can find this angle. Okay, we find this angle first. What do we have? This is the hypotenuse. All right, this is beside the angle, so therefore this is the adjacent. So according to the SOHCAHTOA, we should use the one that have adjacent and hypotenuse, which is the cos. That means cos, this is the theta, cos theta equals to adjacent over hypotenuse. That is 4 2/3, yeah? It's 2/3. So cos theta equals to 2/3. So if we want to find the theta, it will be the arc cos of 2/3, yeah? So this one we have to use the calculator. So what is arc cos of 2/3? All right, so we will just shift the function of cos, then so that we can call the arc cos of 2/3. So 2/3. So we will have this to be 48.19 degree. So that will be 48.19 degree. Let's round off to 1 decimal place in this case. Normally, the for degree, for angle, right, I will just round off to 1 decimal places. So 48.2 degree. Okay, and then we need to change that into radian because the question wants us to give the answer in the radian. So how do we change it to radian? We times with the factor. Okay, since radian should be the unit, so we have to put the pi radian on top. So that degree and degree cancel off. We just left our unit in radian. So this one, you have to take the calculator. 48.2 times 3.142 and then divided by 180. So we have 0.8414 radian. 0.8414 radian for significant figure. So we have done the first part, the theta in terms of radian. Next, we need to find the perimeter of the shaded region. So our shaded region basically is this one, and this one. Now, there are a lot of things to calculate. So let's write down what we want first. So perimeter of shaded region, okay, equals to, we need the arc RST. So write arc RST. S is a symbol of arc, RST, and also the RT. Okay, so plus RT. Okay, plus, let's put the diagram given here so that I don't have to move my notes. Okay, like this. All right, so RST, RT, and the QR, so plus QR, and then plus the PR, and as well as PQ. Okay, so RT, QR, and PQ, they are straight line. But the question is, how do we find this? Now, we do know that if this is 8, this is also 8. Why? Well, because this is a sector, a quadrant. So to find this one, what do we need to do is we can use the Pythagoras Theorem. So we can find RT using the Pythagoras Theorem. So RT basically is, okay, we do one by one, yeah? Now RST can be found S equals to R theta. S equals to R theta. Our R is 8. So 8 theta. Theta will be pi over 4. Why? Because it's 90 degree. 90 degree basically is pi over 2. Pi is 180, so divided by 2. Okay? All right? So 1/4 or half of the pi. That is for the arc length of RST. What about the R to T? It's a Pythagoras theorem. So 8 squared plus 8 squared and then square root. So we will have 8 squared plus 8 squared and square root. That will be our RT. And at the same time, QR. Where's QR? QR is this one. Again, we can use the Pythagoras theorem. We know that this is 8. This whole thing is 12, isn't it? So we will have 12 squared minus 8 squared and square root. And that will give us the QR. Okay, that's it, QR here. Next is the PR. How do we find PR? S equals to R theta. So our R is 8. The theta over here will be the one that we just found at the on top, 0.8414. And the PQ, so what is PQ? PQ is over here. We have just found PQ, isn't it? PQ is 4, so just plus 4 over there. Plus 4. Okay, so put everything in place. Now we can just use our calculator and calculate it. So this will be 4 pi. All right, and then, well, just use calculator. Four pi. So 4 times pi. Okay, you can use the pi given in the calculator. And then plus bracket, square root of bracket 8 square plus 8 square. Close bracket. Then plus, cannot have too much okay, plus square root of bracket 12 squared minus 8 squared, close bracket, and then plus 8 times 0.8414, and then finally plus 4. So that will be our answer, 43.56. Round it up to 4 significant figure, 43.56 cm. Okay, so that is the part 2. Part 3, we need to find the area of the shaded region. Okay, that will be taking the quadrant minus the triangle here, plus taking the triangle minus the sector over here. So in that case, we will take area of quadrants of sector ORT minus area of the triangle ORT, then the side, okay, plus with the area of triangle ORQ minus area of sector OPR. Okay, so for this part, let's do it. Substituting the formula. So the area of sector will be half r squared. What is the r? R is 8. Half r squared. Half r squared theta. So the theta is, again, is pi over 2. And then minus area of the triangle. So half times the base times the height. So 8 times 8. And then plus the area of the triangle here. So how do we find area of this triangle? We can use the sine rules, half AB sine C if we want. Otherwise, we found the QR just now, isn't it? This is the QR. Yeah, we found the QR just now. So we can use the QR to as our base. So we take half times the base times the height. The height is this one. So the height is 8. And let's find out what is this? The QR. So it's 12 squared minus 8 squared. So let's find 12 squared minus 8 squared. So we square root it. We have 8.944. 8.944. So just put it in here. 8.944. And then minus the sector of this, OPR. Yeah? OPR. So we will just take minus half r squared theta. The theta is, again, 0.8414 for the theta over here. Okay, let's calculate using our calculator. So we have 8 squared times with pi over 2, and then divided by 2. Oops. So 50.27 minus this one, 32, and then plus the side, 8.944, the height, base times height, times 8, and then divided by 2, we will have 35.776, and then minus 8 squared times 0.8414, and then divided by 2, 26.92. So 26.92. Let's group everything together. 50.27 minus 32 plus 35.776 and then minus 26.92. We will have 27.13. 27.13 cm squared. That will be the area of our shaded region. So that's it for the whole question number 9.